If you're trying to break into AI or data right now and you keep seeing job titles like data engineer, AI engineer, data scientist, and you genuinely cannot tell what is the difference or which one should you be going after, this video is going to make it crystal clear for you. I'm going to break down what each role does day to day, what skills do you need, what salary ranges look like in 2026, and most importantly, how do you figure out which path is right fit for you. See, I get it. This can be confusing. The industry has done a terrible job of making these roles distinct. You will see job postings where a data scientist is basically asking you to be an AI engineer. You will see AI engineer job listing, which really just means MLOps. The titles are all over the place. So let me simplify this for you, because once you understand the core differentiation between each roles, everything else starts to click. A quick introduction about myself. I'm Ishwara Srinivasan and I've spent over 10 years working in machine learning and AI. I have a master's degree in data science from Columbia University and I've worked as a data scientist in Microsoft, Google and IBM. I'm currently leading developer relations at Nebius. And I'm building a startup, Gen Academy, which is an AI skill building platform focused on teaching the real things that teams are building in production. I've been creating on LinkedIn for over 10 years now and recently started sharing my content on Instagram and YouTube. If you aren't following me on the other platforms, definitely do that. Alright, here's the simplest way that I can frame these roles. Think of it like building a house. The data engineer builds the foundation and the plumbing. They make sure that the clean water flows into every room, the electricity works, the pipes don't leak. The data scientist is the architect. They analyze the blueprints, figure out the best layout, and use data to make design decisions. And the AI engineer, they are the ones who install the smart home systems. They take the intelligence, the model, the AI and make it actually work inside the house so people can interact with it. Now that's the high level mental model that you need to know. Now let me go deeper into each one because the details matter when you're deciding where to invest your time. A data engineer's primary job is to build and maintain the infrastructure that allows data to flow reliably from point A to point B. They design data pipelines, manage data platforms, ensure data quality, and make sure when a data scientist or an AI engineer needs data, it's clean, accessible, and available at scale. Now, without data engineers, everything else is stuck. Your challenge is to count how many times I say data in this video. Now, here is what I want you to understand about this role in 2026 specifically. The landscape has shifted massively. You're no longer writing SQL queries and managing Hadoop clusters. If somebody tells you to spend months learning Hadoop right now, politely ignore that advice. Modern data engineering is all about lakehouse architectures, streaming pipelines, and AI-ready data infrastructure. The tools that matter right now are Apache Spark and Flink for processing, Kafka for streaming, dbt for transformation, and cloud platforms like Snowflake, Databricks, and BigQuery. For orchestration, you also need to know Airflow and Dagster. Now, the big shift that you need to know is open table formats. Apache Iceberg, Delta Lake, and Apache Hudi are the new standard for how data is stored in lakehouses. They give you asset transaction on cheap object storage, time travel queries, and multi-engine capabilities. Companies are considering entire data stacks around these formats, and data engineers who understand lakehouse architectures are extremely valuable. Now, on top of that, data observability has become a core expectation. So, tools like Great Expectation for validation and proper data contract practices are showing up in every serious job posting. The role has genuinely shifted from pipeline developer to data platform engineer. Now, salary-wise, if you look at current Glassdoor data, it shows that average data engineer in the US earns around 132K with a typical range of 100K to 170K. In San Francisco, mid-level salaries can be about 150 to 180K. Senior engineers at top companies can even clear 200K. The global data engineering services market is estimated over 105 billion this year. The personality fit here is somebody who loves building systems. If you enjoy making things reliable, scalable, and efficient. If you find joy in building the engine rather than driving the car, then data engineering is your thing. Now, let's talk about data scientist role. I want to be real with you because this role has changed a lot since the sexiest job of 21st century era. That's when I started being a data scientist. A data scientist's core job is to extract insights, build predictive models from data. They use statistical analysis, machine learning, and experimentation to help businesses make better decisions. So think A/B testing, customer segmentation, demand forecasting, churn prediction, and even recommendation system. But here is the thing though. In 2026, this role has split into two distinct tracks. The first one is analytics data scientist, which is focused on experimentation, causal inference, and communicating insights to stakeholders. They are running A/B tests and helping leadership make data-informed decisions. Companies like Meta, Airbnb, and Stripe have large teams with these folks. Now, the second track is machine learning data scientist who builds production machine learning models, does feature engineering, and works closely with machine learning engineers on deployment. The second track overlaps heavily with AI engineering, which is why the lines get blurry. Now, skill-wise, you need strong Python, deep statistics, and probabilistic knowledge. You need experience with scikit-learn, XGBoost, PyTorch, and comfort with SQL. But here's what most people miss. Communication skills matter enormously. If you can build a great model, but you cannot explain to a VP why the results matter, you're going to struggle. The best data scientists I've worked with at Google and Microsoft weren't the ones with the fanciest model. They were the ones who could translate complexity into clarity. And also knowing when to use AI models and when not to use them. The goal is not always building the most complex system. At the end of the day, the goal is to build things that move the needle in business. Now, I also want you to know that AI coding assistants have changed the data scientist role as well. A lot of exploratory analysis and basic modeling that junior data scientists used to spend weeks on can now be accelerated with tools like Claude Code and Cursor. But this does not mean that the role is going away. You need to frame the right questions, understand the business context, design experiments properly, and interpret results with nuance. Those are the skills that AI cannot replicate. Now, with respect to salaries, again, falling back on what's there in Glassdoor, the average is around 150K, with the typical range of 120 to 200K. Senior roles at major tech companies can exceed 220 to 250K. Alright, now the AI engineering role. Trust me on this is the role that has absolutely exploded, and it is the one that I get most questions about. An AI engineer builds AI-powered applications and products. They take foundational models like Claude, GPTs, Gemini, Qwen, or DeepSeek and integrate them into real products that users interact with. They build RAG systems, autonomous AI agents, AI-powered search, coding assistants, and every kind of application where intelligence is embedded into user experience. Now, why did this role explode? Now, before the LLM era, building an AI product meant training your own model from scratch. Now, with powerful models available through APIs, you can build incredibly sophisticated AI applications without training anything. Now, that shift created a massive need for engineers who can use these models efficiently and ship reliable AI products. AI engineer positions have been growing 300 times faster than traditional software engineering roles, and World Economic Forum projects that the demand for AI roles will exceed supply by 30 to 40% by 2027. Now, the 2026 skill stack for AI engineer is strong engineering fundamentals first, then building with APIs, databases, system design, and of course clean code. On top of that, practical LLM knowledge, whether it's prompt engineering, function calling, structured outputs, RAG, fine-tuning, evals, and agentic workflows is important. And here's what's defining this year specifically. MCP or Model Context Protocol has become a backbone of agentic systems now. Plus, you need to learn about multi-agent systems. Now, alongside that, Google's A2A protocol standardizes how agents talk to each other. So if you're building AI applications today, understanding both MCP and A2A is very important. Now, this is the part that most people skip. The biggest mistake I see aspiring AI engineers make is focusing too much on the AI part and not enough on the engineer part. If you cannot build a proper backend, if you have never deployed anything in production, you're going to hit a wall fast. Companies want people who can ship. They also increasingly want engineers who can build evaluation pipelines, test for hallucinations, add guardrails, and monitor AI systems in production. Now, with respect to salary in 2026, the data shows that average AI engineer base salary is around 185K with the total compensation of around 210K. Senior AI engineers at top companies with production agentic experience can even see the range between 300 to 400K. Salaries have grown about 10% year over year. Now, quick side by side so you can see the difference clearly. Data engineers' primary output is infrastructure, pipelines, lakehouse architectures, and data platforms. Data scientists' primary output is insights and models, analysis, predictions, and experimentation. AI engineers' primary output is AI-powered products, applications, agents, and systems that end users can interact with. Now, the day-to-day field for data engineers is living in Python, SQL, DBT, Airflow, Spark, and cloud infrastructure. For data scientists, they're going to be living in Jupyter notebooks, doing experimentations, visualizations, and stakeholder presentations. On the other hand, AI engineers live in application code, LLM APIs, RAG pipelines, MCP integrations, and shipping features. And these roles are not locked boxes. Plenty of data scientists transition into AI engineering. Plenty of data engineers also move into AI engineering. The convergence of data engineering and AI engineering is one of the biggest trends in 2026 as companies need people who build data pipelines that serve AI systems. Now, whatever path you start on, you are not locked in forever. So, if you ask me which one should you go for first, let me be prescriptive about it. If you love building systems and want to make data flow reliably at scale, go into data engineering. Start with SQL, go deep, then Python, DBT, one cloud platform like AWS or GCP or Airflow, and lakehouse concepts using Apache Iceberg or Delta Lake. Then build an end-to-end pipeline that ingests from a public API, transforms with DBT, loads into a warehouse, and adds a data quality layer using great expectations. That's a killer first project. Now, if you love analyzing data, you're naturally curious about why things happen, and you enjoy statistics and experimentation, then go into data science. Start with Python and SQL, get solid in statistics, and learn things like scikit-learn and pandas inside out. And build end-to-end analysis projects. A strong portfolio project could be something like building a churn prediction model with a real data set and document your thought process right from problem solving to evaluation and explain what actions a business should be taking using that output. See, in 2026, the key differentiator is framing the right questions and communicating these results clearly. It is not just about running a model. And if you love building products and you get excited about cutting edge AI, then go into AI engineering. Get your software engineering fundamentals solid first. Then learn about how LLMs work practically. I would recommend you build a RAG application with a vector database like Pinecone and build an AI agent that uses tools like MCP. Ship it and put it on your GitHub. Then I would recommend learn either Anthropic or OpenAI SDK deeply and understand function calling and structured outputs and build evaluation pipelines. That is what is going to set you apart in 2026. Now, all the resources and recommended reading is something I'm going to add in the description below. If you have not subscribed yet, hit that subscribe button and turn on the bell icon. I regularly post about AI and ML career tips, free resources, educational explainer videos, and my journey as an immigrant in the US building a career as an AI leader. If any of that resonates, I think you'll get a lot of value from this channel. Now, if you have any questions, please feel free to drop that in the comments below. I try to read as many comments as possible and reply. Now, one more thing. If you're serious about going deep on AI engineering, my co-founder Arvind Narayan and I have built a deep dive mastering agentic AI bootcamp at Gen Academy. It covers RAG, AI agents, production deployments, all the real things that teams are building right now. I'm going to add that also in the description below, so go check it out.